In the previous video, we learned that the mix of real and imaginary parts makes a complex number, where a is a real part of a complex number and bi is an imaginary part of a complex number. In this video, we shall develop the algebra of complex numbers. What does the algebra of complex number means? The algebra of complex number means the addition of two complex numbers, difference of two complex numbers, multiplication of two complex numbers, and division of two complex numbers. First of all, let us look at the addition of two complex numbers. Let z1 equal to a plus ib and z2 plus c plus id be any two complex numbers. Then the sum z1 plus z2 is given by the sum of a and c, which adds to give us the real part of a new complex number, and b and d adds to give us imaginary part of a complex number. So z1 plus z2 is defined as a plus c plus I b plus d, where a plus c is a real part of the new complex number and b plus d is imaginary part. Let us consider an example. We have z1 equal to 2 plus 4i and z2 equal to 5 plus 7i. Now, the sum of these two numbers will be equal to the sum of two numbers giving rise to real part of a complex number, and these two numbers will be giving rise to imaginary part of a complex number. So, we can write z1 plus z2 equal to 2 plus 5 plus I 4 plus 7, and we get z1 plus z2 equal to 7 plus 11i. Let us consider one more example. We have z1 equal to 2 plus 3i and z2 equal to negative 6 plus 5i. The sum of these two numbers will be minus 4 and the sum of these two numbers will be 8. So z1 plus z2 will be equal to minus 4 plus 8i. Let us now have a look on the properties of addition of complex numbers. The first property is closure law, which states that the sum of two complex numbers is a complex number, which means the addition of two complex numbers, say z1 and z2, is again a complex number. The second property is commutative law, which states that for any two complex numbers z1 and z2, z1 plus z2 is equal to z2 plus z1, which means the order of addition of two complex numbers does not affect the result, as 2 plus 3 and 3 plus 2 both are equal to 5. The same is the case with addition of two complex numbers. So the third property is associative law, which states that for any three complex numbers z1, z2 and z3, following condition is true. As we can see, 2 plus 3 plus 4 and 2 plus 3 plus 4 with a different bracket position both gives 9. In the same way, the position of bracket does not affect the result in the complex number also. The fourth property is additive identity, which states that there exists the complex number 0 plus I0 denoted as 0 or the 0 complex number, such that for every complex number z, z plus 0 equal to z. It is the same case as adding 0 to any number x, which results x itself. So the number which on adding to another number x gives x itself is called additive identity. The fifth and the last property is additive inverse, which states that to every complex number z equal to a plus ib, we have the complex number minus a plus I minus b denoted by minus z, such that z plus minus z equal to 0. This is the same as adding minus x to x so as to get 0 as a result. Here minus z, which is minus a plus I minus b, is called additive inverse, which on adding to a plus ib gives 0 as a result. So guys, this was all about addition of two complex numbers. In the upcoming videos, we will be learning the remaining operations, namely difference of two complex numbers, multiplication of two complex numbers, and division of two complex numbers.